Hai, apa khabar? Good morning and how are you, everybody? Fine?
Fine, sir, fine.
Okay. Yes. Okay, Assalamualaikum warahmatullah. Today we will continue our subject, still in chapter 1, instrumentation and measurement. We will discuss about part 2, error in measurement. This error in measurement. So we will discuss this topic today. So there will be about 25 slides. Okay, so it take us about half an hour. Okay, can you hear me? If you have a problem hearing the presentation, then let me know. Okay, types of error. Today we will discuss about types of error, error representation, and also some discussion on statistical analysis for error in measurement. Error. So what is the meaning of error? What is error? Anybody can share?
Salah.
Ralat, yes. The meaning in Malay is ralat. So you have some expectation in value, then you measure, you get your measured value. Your expectation is, we call it true value, and this is when you measure something, you get measured value. Then the difference between true and measured value is called error. Okay. Mana dia punya? Okay. Ada lagi nak masuk? Irfan. Cuba 12, 13. So we have everybody, or one more person should be coming. So the definition of error is the difference between the measured value and the expected value of the measured variable. So the difference, this is the difference between what? Between measured value and expected value of the measured variable. What is measured variable? Anything. We have discussed previous class, any parameter, for example, temperature or time or length. Okay, any parameter. So you have the true value or expected value, and then you have measured value. So the difference is called error. Another definition is the deviation of a reading from the expected value of the measured value. The deviation. Deviation means the difference. The deviation also means the difference. You have one value and you have another value which is deviate from that expected value. Okay, I think you need to remember this definition. Okay, I let this guy coming in first. Mana? Amir Daniel. Okay. Boleh boleh baca. So you need to remember this. Sometimes the question asks you to write the definition. Okay. Error can be expressed in terms of absolute or percentage. Normally we will see percent in terms of percentage. Okay, so but they also expressed in terms of absolute. So what is the difference between percentage and absolute? So what is the difference? Percentage, of course, you know, it should have the percent symbol, right? So we will see. So types of error. So we have 5 common type of error. First is absolute, we have discussed just now. Second is limiting. Third is random. Fourth is gross. 5 is systematic. So how many types of error? 5. 5. So you need to be able to list at least how many type of error? 5. What is that? First, absolute. Second, limiting. Third, random. Fourth, gross. Fifth, systematic. So it could be any apa ni, sequence. It doesn't need to follow this sequence 1, 2, 3, 4. It could be any sequence. 5. Okay, what is this? The number 3, 4, 5 is fall into this category. Static error. Static error is numerical difference between the true value of a quantity and its value is obtained by measurement. Okay. And it repeated measurement of the same quantity give different indication. So sometimes in order to reduce the error, you need to make repeated measurement. You measure the same quantity few times in order to get the average value. So using this average value, we can reduce this kind of error. Okay, generally the fault of the person using the measuring instrument such as incorrect reading, incorrect recording, and incorrect use, etc. So this is the definition of gross error. Okay, gross error is related to the fault of the user, the carelessness of the user, fault, the error of the person conducting the measurement. So it might happen that the person make incorrect reading or incorrect recording or incorrect use of the equipment, etc. So this is fall into gross error. We call it, this kind of error is gross error. Okay. So this error is avoidable and must be identified and minimized if not eliminated. So we can avoid this kind of error and we can avoid so that this kind of error can be eliminated, can be removed. Okay. So gross error is related to human mistake. Gross error is related to the person handling the or making the measurement. Gross error. So what can be the mistake? Incorrect reading. First is incorrect reading. Second is lack of knowledge about the instrument or the process. Third is improper use of instrument, and you can list few more example. Human mistake. Okay, so human mistake is kind of gross error. Next is systematic error. Systematic error is error that occurs due to shortcoming of the instrument. What is the shortcoming? Shortcoming of the instrument, such as defective ni rosak, worn ni dah lama, worn parts, aging, dah lama sangat alat tu, or effect of the environment on the instrument. So systematic error has three in systematic error. We can divide into three types. First is instrumental, second is environment, and third is observational. Okay, instrumental is related to instrument, environment is related to the environment, and observational is related to observation. So this also classified as static. Just now we have mentioned static and dynamic errors. Okay. So you have systematic error. Just now we have, so systematic error related to what? Shortcoming of the instruments. Shortcoming meaning the disadvantage of the instrument, or the weaknesses of the instrument. Weakness, so defective, rosak lah. Worn parts, part yang dah rosak juga, ataupun banyak guna ataupun berkarat. Aging, dah lama, ataupun ada efek daripada environment. Contohnya macam mana? Contohnya guna tempat atas gunung contohnya, ataupun tempat sejuk, cuaca sejuk, terlalu sejuk, tempat salji, ataupun tempat yang terlalu panas, desert dan sebagainya. So that kind of error is related to environmental error. Okay, so let's see the types of systematic error. So we have three just now. First is instrumental, second is environmental, third is observational error. So what is instrumental? Instrumental related to, for example, mechanical structure of the instrument, or related to electronic design of the instrument, or related to improper adjustment of the instrument, or the last one is wrong applications of the instruments. You faham ke benda ni? Okay, tengok dulu. The second type of systematic error is environmental error. For example, the environmental factor to the instrument is the temperature, humidity, barometric pressure, or magnetic or electrostatic field. So environmental factor means, let's say you have one instrument which is suitable for use at normal temperature, or normal keadaan suhu bilik, normal suhu, normal temperature. But if you use that instrument at different environment. For example, you are using at another country which have winter, for example, cuaca musim sejuk, ada suhu, the temperature can go down to minus 20 degree, for example. But the instrument should only operate at normal temperature, normal suhu bilik, room temperature, 25 degree, like here in Malaysia. So if the same instrument being used at certain out of range temperature, for example, you are using in America or Kutub Utara or Russia, for example, using the temperature during the winter can go down to minus 20, minus 30. So that kind of instrument, it might work, but it might give you some environmental error which fall into systematic error. Okay. The third one is observational error. Observational factors, for example, parallax and estimation of the meter scale. Okay. So what is actually systematic error? You boleh faham tak systematic error apa?
Kurang.
Okay. The systematic error means the error is systematic di dalam sistem, bersistem. Meaning, even though the equipment or the instrument still giving you the value, the reading, and you take the reading, but you might not realize that the reading is having error. Because the instrument is not working in the design environment or design in the design environment. Okay, contoh you ada temperature, you ada thermometer. That thermometer, katalah dia optimum operational temperature dia dalam suhu bilik 25 degree. So if you using the same instrument to measure temperature at different temperature range, yang saya bagi contoh ni minus 20 degree at in Russia, for example, or you are using that instrument instead of using at the normal sea level dalam keadaan dalam kampung kita, you are using that instrument at different pressure. You bawa guna untuk measure temperature di atas Gunung Kinabalu contohnya, which having 1000 meter berbanding aras laut. So dia pada tempat Gunung Kinabalu tu, dia punya pressure different. Bukan lagi pada satu ATM. Macam at normal sea level macam tempat kita. So it might give you some error. Environmental error. Okay. Okay. So the third one is observational error. Observational means when you are taking the reading, so you might have parallax error. Parallax ni macam kita ambil measurement, kita ambil reading dalam temperature thermometer ataupun level value, ia ada error parallax. Parallax ni sepatutnya you dah belajar dalam sains dulu masa tingkatan 4, tingkatan 5 dululah, parallax error. So something related to observational error. Macam mana kita memandang bacaan tu, sengat dia tu, kita catatkan nilai sesuatu ketinggian ataupun sesuatu bacaan isi padu biasanya. So it is called parallax error, which is fall into this kind of observational error types. So this observational is one of systematic error. Okay, next is instrumental error. Instrumental error is combined accuracy and precision of a measuring instrument, or the difference between the actual value and the value indicated by the instrument, reduced by proper maintenance, use and handling of instrument. So now you have instrument. So this instrument, apa ni? Ni apa? This is V ya. So V is voltmeter. So this is a voltmeter. So this voltmeter can give you instrumental error. Why? Because this instrument, the voltmeter, might have incorrect spring tension, or it has friction in meter movement, or it can have improper calibration, or it can also have faulty instrument. So if, for example, you have this instrument, for example, you go to the lab and you have that instrument and you make measurement, that's it, you get the value. So but the value might have error. So that kind of error is called instrumental error. Why? Because that instrument could have all this: incorrect spring tension, or the friction of the meter movement, improper calibration, faulty instrument. So this kind of error can fall into instrumental error. Okay, so this is instrumental error. So something that happened to the instrument which cause that the instrument give wrong value, wrong measurement. So that is called instrumental error. Okay. Environmental error due to external condition of the measurement. Yeah, instrumental error. So environmental error. Environmental error is due to the external condition of the measurement. For example, effect of change in temperature. So temperature ni tadilah high temperature or low temperature. High temperature normally in the desert, in the desert or the hot country, or otherwise, or in the cold country, for example Russia. So you have this kind of problem in temperature change. Another one is humidity, barometric pressure, electrostatic field, and so on and so forth. So the third one is observational error. So this is what is called a parallax just now. Errors that introduced by the observer, the person that in charge to take the measurement. The two most common observational error are probably the parallax error introduced in the reading a meter scale. So this is parallax error. Instead of taking measurement from this angle, so the person take the measurement from this angle, which give a little different or deviation. Okay, so this is the parallax error. The expected value should be this value, but when we measuring, we taking the value from this angle, so the person will get a little bit deviation from the expected value. So this is the error. So this kind of, I think you have seen this before, something like this. So this is called parallax. They call it parallax. So this parallax is fall into observational error under systematic error. Okay. So this systematic error, here we have discussed just now about the systematic error. There are three type of systematic error. Okay. So this systematic error can be avoided. So instrumentation error, environmental error, and observational error. So how we going to avoid, to eliminate this error? Okay, let's see about instrumentation error. So yeah,
Sir, yang paralel tu kan, dia ada macam titik buta.
ada apa?
Contoh macam kalau belajar sains dulu kan ada macam lihat daripada pandangan atas akan ada nampak titik buta macam tu. Dia ada.
Oh, titik buta.
Gitu.
Titik buta. Ini teori saja, kita tak ada buat praktikal. So this is apa maksud titik buta tu? Maksudnya apa? Maksudnya kalau tengok daripada mana dia tak nampak apa?
Contohnya macam macam mana cakap sekejap. Macam pandangan kita macam terkabur masuk dia. Macam kalau kita buat kereta,
Blind spot.
kita akan
Blind spot lah, tak nampak. So dalam terms kita ni, kita tak ada discuss pasal blind spot. Cuma kita just sentuh pasal parallax effects. Ya, mungkin kalau certain angle, you ambil certain angle ni. So ni kan, ini apa benda ni dipanggil? Tabung uji ke? Ke apa ni?
Tabung uji.
Kan? So there might have a certain blind spot, but we don't discuss here. Meaning we just discuss in general about parallax effect. So if you take this angle, if you increase this angle, let's say tengok dari sini kan, boleh nampak. So sampai certain value of the angle tu, you dah tak nampak lah. For example lah. So after that we call it blind spot. Boleh lah. So mungkin adalah blind spot. But all those spot tu error lah. All the reading yang you ambil kalau tidak selari dengan meniscus ni, so bacaan tu adalah error. Itu je lah dia nak beritahunya. So kalau blind spot, you tu tak nampak apa. Macam mana nak ambil bacaan? Kan? Okay. But in our class, we don't discuss about blind spot in parallel error. That is too detailed. You might go detail later on the parallax effect, but here it's not included lah. We don't discuss about that. Okay.
Not sir.
Okay. So how to avoid systematic error? So first we discuss about instrumentation. So if the instrument is good, then there is no error lah. So how to make sure that the instrument is good? Select the suitable instrument for particular measurement application. So first is, of course, you need to use a suitable instrument for particular measurement. Okay, the second is apply correction factor after determine the amount of instrumental error. So we need to correct correction factor. Third is calibrate the instrument. So 1, 2, 3. Select suitable instrument for particular measurement application. Second is apply correction factor after determine the amount of instrumental error. And third is calibrate the instrument against a standard. Number 3 ni is common. You need to calibrate the instrument. After certain time, then let's say 1 year or 2 years, 5 years, they do the calibration. Okay. Number 2 is how to avoid environmental error. So the first is you can use air conditioning. Ini apa maksud dia? Number 2 is hermetically sealing certain components in the instrument. Number 3 is use magnetic shields. Ini apa ni? So this is how to remove certain problems. For example here, you see environmental error is due to temperature, humidity, barometric, and electrostatic. Okay, so you need to remove all these problem. Okay, so temperature you can use air conditioning. For example, you see the certain place they have air conditioning. In order to make the temperature constant, in order to keep the temperature at certain value. Okay, so they use air conditioning, or sometimes we call it temperature control. Number 2 is hermetically sealing certain components of the instrument. So what is this? So this is you seal the instrument. Sealing means bagi dia kedap udara ataupun tidak so that it doesn't interact with the humidity. Humidity ni macam wap air lah. So wap air dia boleh menyebabkan certain components berkarat. So in order to remove that humidity problem, humidity factor, you need to seal the instrument or the certain components of the instrument so that the instrument is not affected by humidity. Okay. Third is magnetic shield. Magnetic shield ni if you have that magnetic problem. Contoh macam mana you ada magnetic problem? Saya boleh bagi contoh. Okay, for example, you have instrument in power substation, TMB. Okay, so TMB, the power substation, let's say it has how many? 33 kilovolt, for example. So when it operates, it gives a lot of magnetic. So the instrument inside that substation, certain instrument need to be shield magnetically so that it doesn't affect the measurement of the instrument. Okay. Next we have observational error. Observational factor, ensure the angle of ice is perpendicular to the scale. Ini tadilah, ini cerita pasal parallax. So you need to make sure that the ice is perpendicular to scale. Tempat yang kita nak baca, nak ambil bacaan tu. Okay. And the second is correctly estimate the scale to reduce the error of reading. So you need to make sure that you are reading the correct value of the scale. Scale ni di skala tu lah yang kan. So skala ni dia ada yang besar, ada yang kecil. So kena make sure correctly reading the scale so that we can reduce the observational error. So that's it. So how to avoid systematic error? Kita ada 3. Soalan macam ni biasanya dia akan minta you discuss. Okay, discuss steps or how you can avoid systematic error. So this is the way lah you describe avoiding systematic error. Okay, next is random error. Random error is errors that remain after gross and systematic error have been substantially reduced. As a result of noise and interference, backlash or ambient influence, and so on, generally the accumulation of large number of small effects may be of real concern only in measurement requiring high degree of accuracy. Such error can only be analyzed statistically and due to unknown reason. Okay, so even after you remove gross error and systematic error, you still might have another error, which is called random. So from the word itself, you know it is random. So what is random? Don't know. It can be from unknown cause. Tak tahu sebab apa. From unknown. Okay. For example, from noise or from interference, ambient influences. Ambient ni alam sekitar, kita punya environment, and so on and so forth. Okay. It also can happen due to accumulation of large number of small effects. Small effects, small effects accumulate and it become random errors. Okay, but this kind of error is only real concern if you need very high degree of accuracy. So if you don't need very high accuracy, then random errors might not can be considered okay. So it can considered as boleh diabaikan lah, boleh diabaikan. Okay, so such error can only be analyzed statistically. So you need to do very it is very quite difficult to be analyzed. So you need to be a lot of analyzing so that we can know that there is a random error. Otherwise, it's okay. Okay. So this next we have how to reduce the error. So as we know that the error is the difference between expected value and measured value. So we need to reduce so that we measure as close as possible to expected value. So first, we have three parts. First is before the measurement. Second is during the measurement. And third is after the measurement. Okay, so what you need to do to reduce the error before the measurement. So before the measurement, first is the method or procedure of the measurement should be correct. Second is the characteristic of the parameter. So what you need to make sure what is the characteristic of the parameter. What is the parameter? And so on. Parameter means something that you measure. For example, temperature, time, length, speed, whatever. So you need to know the characteristic. Third is the quality, time and cost, instrument capabilities, knowledge of measurement, acceptable results. So you need to define the level of the quality of the measurement. Is it accurate, very accurate, very accurate, or just okay? normal measurement. Okay, and number 4 is you need to decide what is the instrument to be used for the measurement. Okay, now, second is during the measurement, we have to make sure quality, best instrument chosen, suitable position when taking the data, and so on. Quality. Number 2 is safety. So make sure that the safety is first priority. So that there is no electric shock, no overloaded. The instrument is not access the limit, and so on and so forth. Okay, and number 3 is sampling. Observe parameter changing, taking enough sample. So when you are measuring something, make sure that you are taking enough measurement, enough reading, enough sample. Okay, and observe the parameter changing. If you are taking the temperature, so you need to observe how the temperature rise, how the temperature going down, and so on. Okay, and then when you finish, first is analyze the data in terms of mathematics or statistic. Okay, this you might need to use some software, for example, or you need to use the calculation. You need to use some equation. So this happen after measurement. And lastly, you make the report. Full result must be reported completely and accurately. So normally after the measurement finish, so the report should be prepared. You need to prepare report about that measurement. So this is steps in taking measurement, and certain steps we need to do it properly so that we can reduce the error in the measurement. Okay, next is limiting error. Manufacturing limitation to the accuracy of an instrument, stated as percentage of full-scale deflection, increases as measured value less than full-scale deflection. So we have another one is limiting error. Limiting error is if is given by the manufacturer. Okay, so let's say you have 1 meter. So that meter have limitation, so that the manufacturer will give you the limiting error in terms of percentage of full scale. Percentage. So limiting error is in terms of percentage of full scale. So the limiting error will increase when the measured value is less than the full scale deflection. Apa ni maksud dia? Maksudnya, let's say you have some meter. Your meter can measure from 0 to, let's say you have 1 meter, whatever meter lah. Your meter can measure from 0 to 10. If you're measuring this temperature, so you're measuring from 0 to 10 degrees C, for example. So let's say your manufacturer say this have a limitation, 10% error. Okay, so 10% limiting error. Okay, if this error will increase if you measure value less than full scale deflection. So if you measuring full scale, if you measuring, let's say, at 10 degrees Celsius, so you can have 10% error. So if you measuring at 5 degrees C, meaning that less than full scale, this limiting error will increase. So this value will increase, will become higher. Okay, so now we go for certain some calculation in error. So we discussing the error. We have some simple calculation. Simple calculation. So in this topic, we have a simple calculation about the error. Okay, in terms of mathematics, error can be expressed in this equation. So we remember again the definition of error. So just now we have discussed the definition of error, which is the difference between expected value and measured value. Okay, so this is, we have discussed this before. This is the this is the definition of the error. So here this definition is called absolute error. The absolute. So what is absolute error? Absolute error is written as a small e. Small e. Absolute error is the difference between expected value and measured value. So expected value is y. Measured value is x. So the difference when there is different, then it means minus or subtract. So E, from this definition, we can derive the simple equation for absolute error. So absolute error is E equal to Yn. Yn is what? Expected value minus measured value x. So you have the absolute error is Yn minus x. Xn. Okay, so from this equation, we can have another representation of error, which is called percentage error. So this absolute multiply by 100%, we got this percentage over what? So this E over Y. Y is expected. Okay, so this Yn over Xn is E, right? So this one E over Yn, which is the expected value or the true value, multiply by 100%. So you get this percentage of error. Okay, the next term is accuracy. Accuracy means the degree of exactness of the measurement compared to the expected value. So you have another one, you have also here expected value. Okay, A is the relative accuracy. Relative accuracy, the equation is 1 minus Yn minus Xn over Yn. Ini apa ni? Ini ialah percentage tadi kan? This part. This part. Percentage. But without this 100% lah. So 100% or 1. Okay, so you have accuracy is A equal to 1 minus error. So percent of accuracy is 100% minus percent of error. So you get A darab dengan 100%. Sama je ni. It is terbalik lah. Boleh? Equation ni boleh?
Saya
So
tak
you
faham.
have error. You have 1 ataupun 100%. Boleh 100%. 100% is 1. Kan? 90% is 0.9 kan? 50% is 50 over 100 kan? So 50% is 0.5. So now you have 1, which is 100% lah. So accuracy is 1 minus error. Percentage of error. So you get percentage of accuracy. So let's say you have, this is, nampak ke ni? Okay lah, let's say you have 1 meter. 1 meter. This is the expected value. When you make measurement, let's say you get 0.9 meter. This is for simple discussion. So the expected value is 1 meter, but you measure, you get 0.9. So what is that? In terms of error, this part. So absolute error is 1 meter minus 0.9, which is 0.1. 0.1, error is 0.1. Absolute error. But percentage error is 1 minus 0.9 over 1 multiplied by 100%, which is 10% lah. So you are making 10% error. Okay. So what is the accuracy? Accuracy is 1 minus your percentage of error, which is 1 minus 0.9. Sorry. But accuracy in terms of 0 to 1, 0 is not accurate at all, 1 is 100% accurate. So what is the accuracy of your reading? Accuracy is 1 minus 0.1, which is 0.9. Or you are making 90% accurate, meaning that if the length is 1 meter, then you make the reading 0.9, it means that you are making 0.9 accuracy or 90% accuracy your reading. Your error 10%. Macam tu lah. So accuracy and error, the relationship between accuracy and error. Okay, ini dia buat susah je lah, equation ni macam ni lah. Okay, the second one is precision. Precision is a measure of consistency of or repeatability of the measurement. So precision, if you make many times, the measurement many times, so it will measure the consistency. So let's say you take measurement, sometimes you get 0.9, sometimes you get 0.95, sometimes you get 0.99. So this you need to calculate the precision of your measurement. So there goes, you have this equation. Precision is 1 minus xn minus xn bar over xn bar. Ini ialah modulus, absolute value. Xn is the value of the nth measurement. N measurement means so kali pertama you measure dapat 0.9. Itu ialah x1. Kali kedua you measure dapat 0.95 for example. Itu ialah x2. So kali ketiga you measure dapat 0.99. Itu ialah x3. So berapa banyak you measure, you compare lah, akan dapat, nanti you masukkan dalam equation ni, akan dapat nilai precision. So the precision give you measurement of consistency or repeatability of the measurement. So ini ialah contoh. This is the example of, ni apa ni? Kita panggil apa? You ada lagi ke tak dalam kelas ni? Ada lagi? Semua orang ada.
Ada bro.
Sekejap, ada sikit lagi. 2-3 slide lagi. Okey ini ialah contoh kita panggil apa? Target. You nak panah ke, you nak tembak ke, kan? So ini macam ni. So sometimes you have like this lah. Kat sini tak ada precision, tak ada accuracy. Yang accurate-nya dia nak tembak kat sini. Kan, you memang nak tembak kat sini, mata banyak, tepat. Tapi ini tak tahu kat mana, tak kena. Okay, yang kedua, you target at certain place. Semua tembak kat sini. Tapi tak kena kat sini. You nak kat sini. Tapi dia kena kat sini semua. Yang ni, satu lagi ialah tembak kat sini. Memang kena lah. Kena dan banyak kali. Alamak, ada call. Kejap lah, nantilah. Saya tak angkat lah. Okay. So, in terms of accuracy, boleh describe macam mana? Accuracy and precision. Okay, yang ni not accurate, not precise. Tak ada, precision tak ada, accuracy tak ada. Yang ni dia precise tapi tak accurate. Gitu kan? Dia kena satu tempat tapi tak tepat. Sepatutnya kat sini. Yang ni high accuracy, high precision. Bahasa Melayunya apa? Precision ni. Accurate apa accurate? Tepat. Precision?
Ketepatan.
Ha?
Tepat. Ketepatan.
Ketepatan. Ya, mana sama.
Sama je.
Sama kalau dua tu.
Nama lain.
In terms of kita punya ni tak sama. Kita panggil ni apa benda lah. G2 boleh G2.
Oh, gitu.
Oh, gitu.
Lebih kurang lah. Tapi term yang berbeza yang akan sama sebab accuracy means exactness. You memang nak macam tadi tu lah tempat tu. Tempat tuju yang tengah tu. Yang ni consistent. Consistent mean you can make the same, you can repeat the same measurement each time you measure that parameter. Okay, Okay, this is the example. Okay, boleh tengok example lah. Ya. Ya.
Tutup mic.
Ha?
Prof, presiden tadi apa nama dia? Kepadu apa?
G2. Accuracy and precision. Mana dia punya desktop? Kat mana? Okay, example. Ini yang kita discuss just now lah. Macam mana exit ni? Kat sini. Sekejap. Okay, boleh cuba yang ni dulu. This is the example lah, contoh latihan. Soalan dia macam ni lah. Daripada kita punya discussion tadi. Expected value of a voltage across a resistor is 10 volt. Nampak macam mana ni? Tak ada dah. Okay, 10 volt. So, however measurement yield a value of 8. Macam saya kata tadi lah, you ada satu value. Dan contoh ni voltage. Dia expected value is 10 volt. So, you make the measurement and you get 8 volt. Boleh faham situasi ni? Okay. Kalau you boleh faham, you boleh relate lah. Cuba kira.
Dapat 2.0 B. Voltage.
You dah ada kan jawapan dia. Absolute error. Absolute is nilai dia. Nilai error ni. So, E lah tadi. E is equal to Yn. So, yang ni Yn ialah, you kena tulis dulu. Yn ialah 8 ke apa?
10.
Okay. Yn ialah 10. So, 8 ni apa?
8 tu YE.
8 tu XN.
Laju je kerja aku. 8.
Prof, macam mana mau tahu tu YN ataupun XN?
Yn ni expected value. Expected dari perkataan ni. Expected ni maksudnya theoretical value, perkataan lain. Theoretical. Tu tak idea ni, theoretical. Maksudnya nilai yang sebenar lah. Yang ni ialah measured. Measured value ataupun measurement. Okay, so error dia lah, you boleh nampak lah ni kan. Sepatutnya 10 tapi dapat 8. So error dia ialah 2. Minus XN. 2 pun. Percentage error. Percentage ni ialah error ni, E tadi bahagi dengan apa? Bahagi dengan expected value ataupun theoretical value ataupun true value gitu kan. Yang sepatutnya lah. Okay. So 2 ni bahagi dengan percentage kan? Percentage. You kena bahagi dulu. 2 bahagi 10. Tak dengan 100%.
25.
20% lah. Sebab tu you kena tahu ni bahagi dengan true value. Expected value. Kalau you bahagi dengan 8, you akan dapat 25 tadi tu. Okay, so 20%. Relative accuracy apa? So kita kata accuracy tadi. Accuracy ialah 100%. 100% ataupun 1 lah. 1 minus mana apa?
10.
2.
1 minus
8.
1 minus 8. 1 minus 2.
10.
1 minus apa?
Maybe 8.
10.
Accuracy. 1 minus 10. Tak boleh lah. 1. Mesti daripada something daripada ni. You nak manipulate macam mana? 1 minus error kan? Error tu 20%. Bahagi dengan 100%. Ataupun 20% ni sama dengan 0.2 kan? Ni apa ni?
Ya,
0.8.
0.2.
Relative accuracy 0.8. Maksudnya apa? Maksudnya dia 80% lah. 80% error. Kalau 1, tu mana 100%. Macam tu. Percentage accuracy ni darab 100 lah. Ini darab 100. So, you dapat 80%. Betul?
Betul.
Mana ni? Mana? Dia tak pergi.
Accuracy tu, Prof, dia darab dengan 100 ke? Yang 0.8 tu darab 100 tu?
Kalau relatif, dia antara 0 hingga 1. Kalau percentage, 0 hingga 100%. So, maksudnya yang ni darab dengan 100 lah. So,
kalau yang relatif tu, saya letak 0.9 tu macam mana, Mat?
Ini tak dapat 0.9 sebab measurement asal dia daripada 10, you dapat 8. Kalau dia kata sini, the measurement value is 9 volt. And then you akan dapat relative accuracy 0.9. Boleh? So percentage
Boleh.
90%. Macam tu lah. Mana ni? Slide ni tak jalan eh? Kenapa slide ni tak jalan? Saya tulis ke apa? Boleh ya? Next.
Boleh, Prof.
Mana ni? Mana kita punya... Kenapa saya tak jumpa dia punya ni? Ya. Dekat mana? Port. Apa? Slide ni lekat ni. Ni jawapan dah ada. Okay, dah ada. Okay, next. Baiklah. Okay, example 2. 300 volt voltmeter is specified to be accurate within 2% full scale. Ni apa ni sebenarnya? Ni error apa ni? 2%.
Positif 2%.
Apa nama error ni?
Accurate.
Nama dia tadi, jenis error tadi.
Error.
Nama apa? Ni limiting error. Tadi ada kita discuss limiting error.
Ya, limiting error.
So voltmeter ni full scale. Ni full scale dia berapa? Ni 300 volt. Full scale. Tapi kalau dia baca pada 300 volt, dia ada error 2%. Okay. Calculate the limiting error when the instrument is used to measure 120 volt. Tadi kan saya dah cakap kalau ada satu benda tu dia kalau kita measure at full scale dia ada error certain percent.
Kalau dia 300
Apa kalau kita
volt,
measure tadi kan kita bagi contoh 10%. Kalau kita measure separuh dia akan jadi makin limiting error akan jadi makin bertambah. Kalau full scale 2%. Kalau separuh error ni akan bertambah. Okay. Sebab tu kita kena measure the value as close as limiting, as close as full scale. Kalau you ada temperature, you ada thermometer for example 0 hingga 100 kan? You ada dua contohnya. You ada dua thermometer, satu 0 hingga 100, satu lagi ialah 0 hingga 40. Boleh? Katalah kita ada dua termometer. Kita nak measure suhu diri kita, suhu you tu. Suhu apa? Suhu badan. Suhu badan berapa? Biasa 36 kan? 36. Kalau 30 sama. Kalau 38 dah COVID lah. Kan? 40 dah COVID. Dah apa? Bergejala. Kalau you nak measure suhu pada 36 degree ni, mana lebih baik? You guna termometer yang range dia 0 hingga 40 ke ataupun 0 hingga 100?
0 hingga 40.
0 hingga 40.
Kan? So, sebab apa? Sebab you measure tu dia close to suhu 36 tu, contohnya macam ni, 36. Close to full scale. Full scale dia 40. Kalau you measure guna termometer yang 0 hingga 100, you punya measurement kat sini 36. So yang ni termometer A dengan termometer B mempunyai limiting error yang berbeza. So semakin jauh nilai measured value berbanding dengan full scale, semakin besar nilai limiting error. Boleh? So this example you have 300 volt full scale, you measure at 120 volt. So the magnitude of limiting error is this. This is the limiting error. Ini 2% over 100. 100 ni apa? 100 ni the value 2% lah ni. 2 over 100 ni ialah 2%. Darab dengan full scale. Ini ialah full scale ni, 300 volt. So this is the magnitude of the limiting error. Maksudnya bila you measure guna voltmeter ni, you ada 6 volt error. 6 volt ni daripada mana? Inilah 2%. Ni full scale ni daripada 300 volt. So maksudnya voltmeter tu daripada 0 hingga 300 volt. So dia ada 6 volt error. Okay. So bila you gunakan dia untuk measure 120 volt, this error is 6% tadi, 6 volt tadi, over nilai yang you dapat 120 multiply by 100. So this is the new limiting error. New error for the this reading. Boleh? So katakanlah yang ni, kalau you gunakan, kalau you measure guna meter ni untuk 300 volt, you akan dapat 2% limiting error. Tapi kalau you guna untuk measure pada 120 volt, you akan dapat 5%. Cuba you measure pada, katalah you measure 50 volt je. Sorry, 50 volt. Katalah the same question, 300 volt voltmeter is specified to be accurate within 2% full scale. Calculate the limiting error when the instrument is used to measure. Instead of 120 ni, yang you dah ada jawapan 5%, you measure 50 volt. Boleh? Cuba kira. So yang ni A, 120 volt, you ada jawapan dah 5%. Kalau you measure 50 volt, so maksudnya kita ada scale 0 hingga 300, tapi you measure 50 je kat sini. 50 volt je. So berapa limiting error dia?
10%.
So 6 bahagi dengan ni. Berapa jawapan dia? 6 ni masih lagi 6 volt ni, 6 volt.
12.
Tapi instead of
12.
120 you measure 50 je. Berapa? 6 bahagi 50 apa?
12.
12.
12.
12. Siapa kata 10 tadi?
Vin. Amen.
Kalau 10% dia measure pada berapa? 60 60. 60 kan? Kalau dia measure pada 60%, 60 volt,
Dapat
errornya ialah
10%.
So kalau measure 120, error dia makin kecil, 5. Okay, example.
Mana dapat 50% tu? 50% tu.
Mana ni?
Ah,
Tak, ini 50 volt.
oh, okey.
Macam
Macam mana aku dapat tu, Prof?
50 volt. Tak. Soalan yang sama, ni kalau measure 120 volt, you akan dapat 5%. Ni calculation dia, dah ada ni calculation dia. 6 volt ialah daripada ni 2 darab 300. 2%, 2/100 darab 300. Okey. Dapat 6 volt. So setiap kali measure guna meter ni dah ada error 6 volt. Itu limiting error. So semakin besar, semakin kecil measurement berbanding full scale, so limiting error ni akan bertambah, menjadi lebih besar. So kalau kita guna, katalah kita measure separuh je, Dia 300 volt tapi you measure 150. 150 150 volt. Instead of 120 you measure 150. So berapa limiting error ni? So 6 over 150 darab dengan 100%.
4.
Berapa?
4.
4%. Okay. So you boleh relate tak? Maksudnya kalau you guna full scale, error dia 2%. Kalau you guna separuh, error dia meningkat menjadi double. Betul? 4%. Boleh ya? Kalau kecil lagi, dia akan jadi lebih tinggi. Kalau tadi kita ada 60 kan, 60 dia dah jadi 10% lah error dia. Kalau kita measure 50, dia jadi 12. So error ni akan bertambah bila semakin kecil nilai measurement tu berbanding dengan full scale. So ini ialah calculation limiting error. Okay. So biasanya untuk soalan macam ni kita ada expected value dan measurement yield ataupun measured value. So ia ada satu nilai expected dan satu nilai measured. Ni sama lah macam tadi. Soalan tadi yang pertama ni. Okay, dia untuk soalan dia boleh jadi apa-apa sajalah ni. So you kena faham lah. Kerana dia ada 4 step ni. Absolute error, percent error, accuracy dan percent accuracy. Boleh. Ni sama macam example 1 dia. So kalau soalan kuis ke apa, dia akan ubah nilai ni je lah. 4.9, 5.0 ke 4.5 ke 4.0 ke. You kena tahu ya macam mana nak calculate. Boleh? So yang ni dah ada jawapan dia. You buat lah. Macam tadi lah. Ini ialah 5 tolak 4.9 dapat 0.1. So 0.1 ni bahagi dengan 5. Dapat 2 kan? 2% darab 100 lah. So ini ialah 0.1 bahagi dengan 5.0 darab dengan 100%. 2%. So mana YN ni? YN berapa? YN berapa?
Lima.
YN 5. SN 4.9.
4.9.
Faham lah tu. Okay, beres. So yang ni you boleh tolak lah. Yang ni. Ini tolak yang ni kan. 0.02. 1 tolak 0.02. 0.02 ni lah 2% lah. Okay, so you get the accuracy in terms of percentage. Yang ni darab dengan 100. 0.98 darab dengan 100 dapat 98%. Okay, ni you discuss buat sendiri. Ini kita dah discuss tadi kan. The instruments are guaranteed to be accurate within 1%. Ni 1%. Full scale. Full scale ni apa? Berapa full scale ni? 150. So if the voltmeter reads 80 volt on its 150 range. Range ni maksudnya full scale lah. And emitter reads 70 of its 100 range. Range meaning full scale. Calculate the limiting error for the power calculation. Boleh? Ada jawapan tak? Answer 3.305. Dah ada jawapan. You kena buat lah. Nanti okay, that's all. Sekejap. Boleh yang ujung tu buat Yang ujung tu you buat lah. Nanti macam mana ni? Ya, saya dah hilang dia punya. Okay. Berapa dah? 12 lah. Kelas habis masa dah. Okay. Rasa kelas kita macam tu dulu hari ni. you kena buat latihan tu, nanti esok saya tanya. Boleh?
Boleh,
Boleh.
Prof.
Macam ni, kita ada perubahan sikit.
Ah.
Kalau esok kelas you free ke?
Esok pukul berapa, Prof?
Esok yang jalan jadual pukul 10. Tapi dia tulis B. Sebelum ni, B ni kalau kelas biasa, kita tak buat kelas. Sebab B ni lab. Boleh?
Tak pasti ya, Prof, esok.
Nanti saya discuss, kita discuss dalam grup WhatsApp lah.
Okey, boleh.
Tak apa. By the way, you boleh access ke Kalam tengok video tu?
Boleh.
Kadang-kadang boleh. Kadang-kadang.
Kalau boleh okeylah, nanti saya nanti saya upload kat YouTube video tu. Video tu daripada section lain Dr. Yasmin. So nanti tak apalah, you tengok kontennya sama. So kelas kita dah habis masa ni. So that's all. You ada kelas lain ke masa ni?
Ada, Prof. Falsafah.
Ada, Prof.
Okay. So that's all. Thank you. Terima kasih semua.
Kehadiran, Prof, macam mana, Prof?
Attendance. Kat mana tak attendance you ni? Dah hilang lah dia punya apa? Attendance ni. Tak apalah. Saya anggap semua datang lah tadi. Okay, that's all. Thank you very much.
Thank you,
Okay,
Prof.
bye.
Thank you.
Thank you, Prof.
Masuk kelas falsafah, keluar.
Falsafah, tolong.
Amirul tidur ke apa bodoh?